Hello and welcome back to the 5-6 notes. This is part 3, and this is the other half of integration by substitution, and we want to be able to evaluate definite integrals while using substitution. Okay, so we do have to take a few things into account when we do this, and there are two different methods on how to do this. I will do both methods. They both do the same thing, just at different times. But you know what we're doing now, guys, remember, is we are calculating the area under the curve if we have bounds. Okay, if we have a lower bound and an upper bound. In the first part of this section, we didn't have bounds. Okay, we were just taking antiderivatives. But this means we are finding the area under the curve. So let me come in here and let's do method 1 on how to evaluate this. The first thing I'm going to do is rewrite this, because currently it's in kind of an interesting notation with this dx up in our numerator here. What I want to do initially is rewrite this as the integral from 0 to 2 of 1 over x plus 3 quantity cubed, and then put the dx out here. Okay, so this is the integral we want to evaluate. And what I'm going to do is I'm going to do my u substitution. Okay, what I see is I see my inside function here as x plus 3. Okay, and then I see the derivative of x plus 3, which is just 1, then dx. Okay, so let's do this. Let me let u equal x plus 3. So then my integral then is the integral of 1 over u cubed dx. Now here's the interesting thing, is that my bounds for 0 and 2, these are in terms of x. So once I make this first initial u substitution, we have to come back and remember that our bounds are in terms of x. I'm going to put x equals 0 and x equals 2. Okay? And what I'm going to do is I'm going to evaluate my definite integral here, take my antiderivative, but I'm going to keep my bounds in terms of x. Okay, so we got to make sure that once we make our u substitution that we note that our bounds are x values. All right, so the next step, let me quickly just rewrite this as the integral from x equals 0 to x equals 2 of u to the negative 3 power. So I can take my antiderivative, and I need to get rid of my dx here. Forgot about that. Okay, so up here, let me find du dx. Du dx is equal to just 1. Okay, if I multiply both sides by dx and kind of just move that over, then I end up getting this, that du is equal to 1 dx. All right. And 1 times dx is just dx, so du is equal to dx. So I'm going to substitute du into dx here and put all my stuff in terms of u. So now I get the integral from x equals 0 to x equals 2 of u to the negative 3 power du. Okay? Now I can take my antiderivative of this, okay? And so let me go ahead and do that, and we're going to get u to the negative 2 power, increase that by 1, and then divide by our new exponent, which is negative 2. And we're going to evaluate that at x equals 0 and x equals 2. Okay? Now, what I want to do is rewrite this as... let me take my u to the negative 2, put that in my denominator, and so I get 1 over, and let me do this, let me do negative 1 over 2 times u squared, okay, evaluated at x equals 0 and at x equals 2. Okay, now what I want to do is go back and substitute what I had in for u, which was just x plus 3. So I'm going to take x plus 3 and substitute that in back down here. And so we end up getting negative 1 over 2 times the quantity, x plus 3, quantity squared evaluated at now just 0 and 2. So notice that when I took my antiderivative and I was using my variable u, I had to make sure that I knew that these were x values. But once I've gone back and changed this antiderivative in terms of x, I can now just have 2 and 0, okay? So now what I can do is just to go ahead and evaluate this, and I get negative 1 over 2 times the quantity 2 plus 3 squared minus negative 1 over 2 times 0 plus 3 squared. And as a result, we're going to get negative 1 over 2 times 5 squared plus 1 over 2 times 3 squared. All right, so now we get negative 1 over 2 times 25, that's negative 1 over 50, and then plus, this gives us 1 over 2 times 9, so 1 over 18. All right, so I just want to add these two fractions together. Let me get a common denominator. I'm going to multiply this by 18 and 18, and this by 50 and by 50. There might be a smaller common denominator, but I'm just going to go ahead and get negative 18 over, this is going to give me 900 plus 50 divided by 900, which is going to give me, what is that, 32? So we get 32 over 900, okay? And this is the area under our curve. Okay, and we can actually simplify this into 8 over 225, okay? And this is our answer. This is the area under the curve. Now, what I want to do, we've done this problem, okay? We've evaluated this integral. It is quite a bit of work. It is tedious. But what I want you to notice here is that we kept everything in the end in terms of x, okay? Now, in the other method, I'm going to put everything in terms of u, okay? So it's the same problem. We know where we're supposed to end up, but let's go ahead and just evaluate this using the other method. So I'm going to zoom in here. First things first, I'm going to rewrite this as the integral from 0 to 2 of 1 over the quantity x plus 3 cubed dx, okay? So the same thing, we're going to let u equal x plus 3, okay? And I'm going to go ahead and rewrite my integral as the integral from x equals 0 to x equals 2 of 1 over u cubed dx, I mean. Okay, so let's come up over here. Let's take our derivative, du dx. This is going to give us just 1 multiplied by dx on both sides. Move that over. So we end up getting that du is equal to dx. So now I get this integral. I get the integral from x equals 0 to x equals 2 of just 1 over u cubed du. Okay? Now what I'm going to do is, instead of keeping my bounds in terms of x, I'm going to change them and put them in terms of u. So I'm going to use what I have here, u equals x plus 3, to help me do that. So I'm going to say, I usually write it like this. I say when x equals 0, okay, I plug that in here and I get u is equal to 0 plus 3. So I get that u is equal to 3 when x is 0, okay? And then when u is equal to 2, okay, we get x, or no, not u. When x equals 2, then u is equal to 2 plus 3, so u is equal to 5, okay? So now what I've done is I've just changed my bounds to put them in terms of u. So when x is 0, u is 3. When x is 2, u is 5. So I'm going to plug that in here. and I'm going to rewrite this as the integral from, instead of writing x equals 0, I'm going to write x is equal, or u is equal to 3. And then when x was 2, u is equal to 5. So now this has changed to the integral from 3 to 5 of, and I'm just going to write it as u to the negative 3 power du. Now, I just need to evaluate this now. Now that I've changed everything in terms of u, I don't have to deal with the x's anymore. Okay, I can just evaluate this integral. So let's go ahead and do that. And this is going to give me u to the negative 2 over negative 2 evaluated at 3 and 5. And let me put this into something I can use, and this is going to give me negative 1 over 2 times u squared evaluated at 3 and 5. And so we get negative 1 over 2 times 5 squared minus negative 1 over 2 times 3 squared. So we get the same thing that we had. Okay, we're going to get negative 1 over 5 squared is 25 times 2 is 50. And then plus 1 over 3 squared is 9 times 2 is 18. And we just know that, from the previous problem that we're just going to get 8 over 225. So, we're going to get the same thing. And I think one of them, you're going to end up doing the same math for either one. It just depends on what you're comfortable with and how you see how to do the problem. Some people really like method 2. Some people really like method 1. So it's really ultimately your choice. We just want to make sure that in the end you get the same answer. So I hope you enjoyed this video. I'm going to go ahead and stop this, and we'll do another one for example 6 and example 7. Thanks.